Thank you. So today we're going to be talking about services that AWS has specifically for data migration, and we're going to talk a little bit about why you would migrate your data and what that actually means. And I'd like to start with an overview of the storage services that we have available at AWS. So you can see that we have block, file, and object offerings in the center of the screen. Of course, for block, that's our EBS service, and that provides block storage to EC2 instances that are running inside of AWS. We have EFS, which is our NFS-based scalable file system. And again, that provides file services via NFS to workloads that are running inside of AWS. And you can actually even connect that to your own data center. And we'll talk about that a little bit later in the presentation. And on the bottom, we have S3 and Glacier, which are object storage. And those are sort of foundational to moving workloads into AWS and moving large data sets and building things like data lakes, archiving data, and sending backup data into AWS. So what we're going to focus on today is the Storage Gateway family, the EFS File Sync product that we launched back in November, as well as S3 Transfer Acceleration and the Snow family. And I want to start off just for a minute talking about Direct Connect. And Direct Connect is a way for you to connect your data center or your large regional offices or remote offices into AWS and into the AWS infrastructure using a dedicated network connection. So you get 1 gigabit, 10 gigabit, multiples of 10 gigabit, and get a direct connection. So you're not going over the public internet, you're going over a private network. And this is going to give you the lowest latency possible. Of course, you can't overcome the speed of light or distance, but you can get a little bit better control about the path that the data is taking, the network is taking, as well as everything that's sort of in the data path. And so you gain some efficiencies there. You're also going to do things like reduce the amount of packet loss and the congestion and things like that you'll typically see if you're going over the internet. You're going to be able to remove a lot of those things, so you get secure, high-performance connectivity into the AWS infrastructure. Now, as you start to think about moving to the cloud, migrating your data and moving workloads, there are a lot of reasons that companies are doing this today. Certainly to have an infrastructure that is more cost effective by only paying for what you're using and not having to go the traditional route that we've seen with storage arrays in the past, or even compute in the past, where you try to guess what you're going to need in 24 or 36 or even longer months, and you buy it all up front. And so what that means is that up front, you're paying a lot of money for the 1 terabyte that you're storing, or 10 or 100 terabytes that you're storing, because you bought 5 years of storage and you actually bought a petabyte. And so certainly over time, the cost per gig is going to go down, but up front, it's fairly expensive, and there's a lot of heavy lifting that you have to do to put that infrastructure in place, have it on the floor, even though you're only using a small percentage of it. So the cost effectiveness and the being able to right-size workloads and right-size, the storage capacity that you're using, because you're only paying for what you're using. And then if we start to look into agility and sort of the elasticity of moving into the cloud, being able to add new instances or add more storage on demand, or with things like S3 and Glacier and EFS, you don't even have to think about adding more storage. You just save more data, and the storage is going to grow, and it's just going to save the data for you, and it's all transparent, and you don't have to think about managing the infrastructure. You're just able to save the data and make use of it in a compute environment, and really reduce the overhead that's associated with that. So moving data into AWS, there are some things that you need to think about up front, and you want to manage for these things and to be able to plan so that you have the best experience for your end users and your customers, to make sure that your applications and your data are available and up and running as quickly as possible inside the cloud, and that you're taking the best advantage of everything that you can do moving into AWS. So we want to think about things like disruption from migrating a data set or migrating an application, speed for how quickly can I get the data there, certainly the cost that that is going to be associated with moving it, if you have to put in additional network circuits to be able to move the data up front very quickly, or if you can do a bulk data move. And then, things like cloud compatibility. You want to make sure that your applications are going to run correctly and that you're not going to have any issues. And so 5 questions to ask yourself as you're starting to migrate data. First thing is, what kind of data is it and where are you going to put it? We have database instances inside of AWS. We have object storage, we have block storage, we have file storage. We have a lot of options, and you want to make sure that you're getting the data in the right place. If you're moving a database in, and maybe it's a SQL database, you might be able to move it directly into one of AWS's managed database offerings, and you don't actually have to migrate the application that's running that database. You can just move the database and have it run and be managed and protected on the AWS infrastructure without having to refactor or retool. If you have a NAS filer and some of the application data is on the filer, you may be able to move that into EFS. So we want to make sure that we get the right data on the right tier of storage. The next is, are you doing this one time? Is this one large migration, or is it ongoing? Are you going to continue to replicate data in? We certainly have a lot of customers that move data in on a continuous basis, and they're processing it inside of AWS. They're getting to results much faster because they can spin up a lot of EC2 instances or use something like EMR to process all of the data. They're getting to results much faster. So you just want to plan in advance to know, is this something like a data center migration or an application migration, or am I going to continuously send data into AWS so that I can process it and even potentially overwrite data that I've written in the past? Next is this a one-way migration, or is it going to be bidirectional? If you're doing a data center migration into AWS, then it's one way. You're moving all of that data in. It's going to live inside of AWS. You're going to have EC2 instances running. You're going to be operating on the data. End users will be accessing the applications. If it's bidirectional, that means that you're going to be moving data into and out of AWS. We have a lot of customers that maintain research environments on premises. So if you think about a biotech or a pharmaceutical company, you have chemists, you have scientists and researchers. They have instruments that are running in labs. And so those instruments are generating large amounts of data, and those customers are moving that data up into AWS. They're processing it inside of EC2, and then the results are getting saved into S3, and they can read that data back out. So they're streaming the data back out as well as writing it into AWS. Number 4, how much data and time do you have? This goes back to what does the network look like if I'm going to do continuous migration or a one-time migration? How much do I need to move at a time? And what's my time frame from when I start to when I want to be up and running inside of AWS? And the last is, what about the WAN? The WAN, if you're not running over a direct connect, if you're maybe running over the public internet, you have an MPLS circuit, you're coming in via a VPN, you want to think about the network connectivity between your data center and AWS, and that's going to affect the 4 other questions in this list. Because if the WAN isn't large enough, you have a very tight time frame and a lot of data, you might run into issues trying to transfer all of that over the network. And the good news is we actually have some tools at AWS that can help you manage that process. The first thing that we're going to talk about is the Snow family of products. And the Snow family is made up of the Snowball, the Snowball Edge, and the Snowmobile. With the Snowball, you get 80 terabytes of capacity, 10 gigabit network connection, and when you copy data and write data into the Snowball and the Snowball Edge, all of that data is going to be compressed and encrypted. And an important thing to note is that the encryption key doesn't travel with the device. So that means that you keep the encryption key, the data's been encrypted before it even lands and is written to disk, and then when you ship it back, everything is safe and secure. So the Snowball Edge and the Snowball, these are both designed to be shipped to you and shipped back to AWS. You write all of your data in. When we get the devices back, we're going to verify that it hasn't been tampered with. These are tamper-evident cases. And we're also going to verify that the BIOS and sort of everything electronically about the device is secure and that it hasn't been tampered with. And provided that nothing has happened, we're then going to copy all that data into your S3 bucket. So the Snowball Edge, here you have 100 terabytes of capacity. You have 10, 25, and 40 gigabit network connections. You also have the ability to write to the Snowball Edge via an NFS client, and it also has its own S3-like API. So if you have an application in your data center that supports the S3 API, you can write directly to the Snowball Edge using that. With the traditional Snowball, you have a client that you load, and that client can even act as an S3 API, or the client can copy the data and write it into the Snowball for you. And then on the far right of the slide, we have the Snowmobile. This is our 100 petabyte device. It's actually a tractor trailer. When you order the Snowmobile, we'll drive it to your data center, you plug it in, you fill it up with data up to 100 petabytes, and then we'll drive it back and we'll move all of that data into your S3 environment inside of AWS. So the Snow family is a way that you can move large amounts of data, and you can do it without having to saturate your WAN, or if you have a location where the WAN quality isn't that great, you can send a Snowball or a Snowball Edge there. But when you're moving large amounts of data and you need to do it quickly, the Snow family is a way for you to be able to do that. To get the process started, it's pretty straightforward. You log into the AWS console, you create a new job, we'll ship you the Snowball or the Snowball Edge. For the Snowmobile, we'll probably talk to you first, but we'll ship the device to you. You receive it, you unlock it, plug it into your network, and then you can fill it up with data, ship it back to AWS. And again, after we verify that everything looks good and is secure, we'll then copy that data into your S3 bucket. So the next thing that we're going to talk about is EFS File Sync. With EFS File Sync, this is a way that you can move data from file systems inside of your data center or your regional offices into an EFS file system, and you can do it very quickly and very easily. And I will point out securely, because everything is encrypted end to end as you're moving the data. So you deploy a sync agent inside of your data center or your regional office, and the sync agent is a virtual machine. So you would download this virtual machine, you deploy it in your environment, and then it connects via NFS to a file server or a NAS device. So you'll have an NFS export of a file system. We'll connect to that file system, and you can copy everything in that file system, or you can connect directly to a subdirectory and just move the subdirectory. And we'll move all of that up into an EFS file system. And again, we do that over an encrypted connection. We also compress the data before we transfer it, and we use multiple TCP flows, and we have a TCP stack that has been tuned for high throughput and to be able to deal with things like packet loss and packet out of orders, things that you're going to see if you're going over a VPN connection over the internet. We've optimized the TCP stack and the performance of the sync agent going into the EFS file system to be able to deal with things like that, so you get the highest performance possible when you're migrating those file systems. Next, we'll talk about S3 transfer acceleration. And transfer acceleration is a way to improve performance when you're writing data to or reading data from an S3 bucket that's maybe far away. So in this case, you can see in our little graphic here, we've got an S3 bucket in US East 1 on the east coast of the United States, and we have a client down in India, and they're uploading data into that S3 bucket. Doing it the traditional way, you would be going over the internet. You're going to have a high latency because you're going a very long distance. And going over the internet, you're also highly susceptible to packet loss and packet out of orders, and those are going to reduce the performance. So even if you have something like, say, a 1 gigabit network, you're probably going to average about 4 megabits per second when you have hundreds of milliseconds per latency, and even as little as 1/10 of 1% packet loss. It's going to dramatically slow down the performance. And so S3 transfer acceleration is a way for you to get around those issues of going over the internet. And the way that it works is the client makes a connection to the AWS Edge location. So this is part of the CloudFront network. It's part of the global Amazon network. So you connect locally. In this case, they're connecting to an edge location that's inside of India. So now, instead of a connection that is hundreds of milliseconds, it's maybe 5 milliseconds. So we've dramatically reduced the amount of latency for the client. It starts to write data. The data is terminated at the edge location, and then it's transferred over the Amazon network, where we have no packet loss. We can manage congestion, as well as we can do things like manage the window size for TCP. And that's when you have a very long connection, lots of latency, also high throughput. That's the way that you can fill up and take advantage of all of that bandwidth that's available by managing the window size and managing some things at the TCP layer. So we do all of that automatically. And there's no software that's required to do this. You simply enable it for the S3 bucket, and then you add S3 transfer acceleration into the URL for the bucket. And all of this is documented in the user documents on how to very quickly and easily turn on S3 transfer acceleration and take advantage of it. And you can see very dramatic performance improvements. On average, we see customers with 100 to 200 times performance improvement when they're going over long distances using S3 transfer acceleration. Next, we're going to talk about the storage gateway family. The storage gateway family enables you to build out hybrid storage solutions where you're connecting infrastructure inside of your data center, your applications, your servers, to the AWS infrastructure. And this is so you can take advantage of things like the durability and the low cost of S3, the low cost archiving capabilities of Glacier, and even data protection with things like EBS snapshots for volumes and for data that's running inside of your own data center. So on the left-hand side, you can see that we support files, volumes, and tapes. These all run as virtual machines, and we'll talk a little bit more about the individual modes in a minute. And on the right-hand side, you can see as targets, we support S3, Glacier, and EBS snapshots. And an important thing to note about the storage gateway family is that all the modes support things like CloudWatch and CloudTrail and IAM for security management, KMS for encryption. They all support the foundational AWS tools, so that if you're using AWS today, the tools that you're using to manage your environment and to monitor your environment, those apply to the storage gateway as well, even if part of the storage gateway infrastructure is running as a virtual machine inside of your environment. So the first thing that we'll talk about is the file gateway. And the file gateway provides on-premises file storage. So you have the storage gateway virtual machine that's running inside of your data center. It's exporting NFS version 3 and version 4.1. So that means that your Linux and Unix workloads, and also your Windows workloads, if it's Windows Enterprise Desktop, or if it's Windows Server, you have an NFS version 3 client built in that you can use to mount the storage gateway virtual machine. And then we have an HTTPS connection. So we have an encrypted connection back into the storage gateway infrastructure. And then that connects to S3 infrequent access, as well as Glacier through lifecycle policies. So when you connect the storage gateway virtual machine to an S3 bucket, you can have up to 10 buckets connected to the virtual machine for the file gateway. That will result in 10 NFS exports. So each bucket is an NFS export. And you can choose when you write data into that virtual machine, is that data going to land on S3 standard, or is it going to land on S3 standard infrequent access? And you can also take advantage of lifecycle policies that will move the data from standard to infrequent access, from standard to Glacier, or from infrequent access into Glacier. So all the flexibility that you have with an S3 bucket today, you got all of that with the file gateway, because all the file gateway is doing is presenting an NFS export or an NFS mount point to that S3 bucket. Now, it's important to note that all of the storage gateway virtual machines provide a caching layer. So you can have up to 16 terabytes of cache for the virtual machine. And that means that any data that you write to the storage gateway is going to be stored locally. It's going to be cached, and you're going to get a fast response back to the application server that the data was written. And then that virtual machine at the same time is going to start streaming the data up into the service. And with the file gateway, we're going to be writing it directly into S3 or S3 infrequent access. And when we write that data with the file gateway, if you were to write, say, word.doc to the file gateway, what you will see in your S3 bucket is an object named word.doc. And if there's a directory structure, say it's users/Everett/my documents/word.doc, we will take that directory structure, all the things in those slashes, and we will turn that into the prefix for the object when we write it into S3 or S3 infrequent access. And so this means that you can migrate data from your application servers inside of your data center, put that data in S3, and you can do things like real-time SQL queries using Athena, or process it with EMR or Redshift. You have all of the analytics tools and the data management tools for S3. You can use those with data that's been written with the file gateway. Now I want to share an interesting use case with you for the file gateway. So this is Halliburton Landmark Services. And Landmark provides services, software, and data center applications to companies in the oil and gas industry. And Landmark was storing oil field data, like seismic data, satellite imagery, things like that, on NAS filers. They were archiving it to LTO drives and then sending the tapes offsite for long-term secure storage. And when a customer would come to Landmark and say, we'd like to look at this data, we want to process it, Landmark would have to request the tapes back. Then they would have to restore them onto the NAS filer, and then they could provide the application data to Petrobank, which is their application, and to their end users, so that their end users and their customers can go process the data. Now, using AWS, the file gateway, and Snowball with S3, Halliburton or Landmark was able to recall the tapes, restore them back to their NAS filer, copy that data onto a Snowball, ship it back to AWS, and then we put it into their S3 bucket. They deployed a file gateway inside of their data center and connected the Petrobank application and the application servers to the file gateway. So they were already using NFS to mount their NAS filer, and now they're using the file gateway. And what that's done is they were able to go from days or weeks to restore the data and make it available to their customers to real time, because they've moved all of the data into S3 standard and S3 infrequent access, and they're accessing it with a file gateway. So now if a customer wants to reprocess data or loads new data in and wants to start working on it, they can do that in real time, and it's now self-service. And they've been able to reduce the time to data for the customers, as well as reduce what they were paying for archiving and managing that archive data by up to 90%. So next we're going to talk about Tape Gateway. And Tape Gateway, now from a migration standpoint, Tape Gateway fits into a couple of different use cases. And after I explain how Tape Gateway works, we'll walk through sort of end-to-end how you would migrate data using a Tape Gateway and kind of where it fits into a data migration workflow. But Tape Gateway presents 10 drives, 1,500 slots, and a robot as part of a virtual tape library. So you connect to it via iSCSI. Your backup software is able to go through to index the library. You create tapes as they're needed on demand, up to 2.5 terabytes per tape. And one thing that's important to know about the Tape Gateway is that when you create tapes, you only pay for capacity that's used. So you could create 100 2.5 terabyte tapes. Each tape will have its own barcode. And if you only write 1 gigabyte of data to those 100 2.5 terabyte tapes, you will only pay for 1 gigabyte of data. So again, as with all of AWS, you're only paying for what you're actually consuming, but you can create all those tapes in advance so that you're ready and your backup application can then index the library, see all of those barcodes, and they can very quickly start writing data into the Tape Gateway. So as I mentioned previously, the Tape Gateway does have cache, so you can have up to 16 terabytes of cache. And what that means is if your backup is, say, 10 terabytes, the entire backup will fit in the cache. If you need to restore data, you'll be restoring out of cache, at least until you do the next day's backup and it purges some of that old data out. But all of your data gets stored up inside of the storage gateway service. And the storage gateway service uses S3 and Glacier as backend storage. So you can't connect directly to the S3 bucket, nor can you see the vaults inside of Glacier. You have to go through the storage gateway service. We do compress and encrypt all of the data before it's written into the service. As well, we also encrypt all of that data with HTTPS as it's being written from the tape gateway virtual machine into the storage gateway service. So the data is compressed, encrypted, and then it uses an encrypted connection. Now, the way that we take advantage of storage, if a tape is in a drive or in a slot inside of the virtual library, any data that's either written to that tape or has been stored on a tape that's in a slot, all of that data is going to be stored inside of S3. So if the tape is still active in the library, that means that inside of the storage gateway service, that data is in S3. If you export a tape out of the library, and you would do this with your backup software, so the same workflow that you have today for writing to tapes and managing tapes, you're going to use that same workflow with the virtual tape library. So you export the tape out of the library, we then mark it read-only, and we make a copy of it into Glacier. So on the previous two slides where we were talking about Halliburton and how they were exporting tapes out of the library after archiving data and sending them off-site, you can think of the Glacier tier as that off-site long-term secure and durable archive. Now, when it comes to migrating data, and you start to look at VTL and think, how would I use a VTL to migrate my data? If you think about how you're managing data today, you've got your backup server, you potentially have a backup disk appliance, you have a tape library maybe for long-term archiving, and then you're sending those tapes offsite into a vault. Now you deploy the tape gateway virtual machine, you connect to the service, and all of those tapes that are in the vault, you now have a choice. You can recall those tapes similar to the way that Halliburton Landmark did, restore them or make a clone of them into the tape gateway, and all of that data gets written up into the service, and then you export those tapes to Glacier, and now that's your archive copy. Or you can just stop writing to your old tape library. Typically, all of those old tapes are going to expire at some point, so you can just stop adding to that stack. Stop buying physical tapes. Stop making archive copies or clone copies into your tape library. Keep your backup disk appliance that's probably doing deduplication, so you can back up there, and now you're making your archive copy into the tape gateway virtual machine, writing that into S3 and exporting it out to Glacier. And over time, your old tape archives are going to start to expire. And as they expire, you take them out of the backup software, you take them out of the offsite storage, you stop paying that fee, and over time, you'll be able to completely remove that infrastructure, potentially have all of your backups going into the tape gateway virtual machine, and certainly your archives going into the tape gateway virtual machine. So it's a way that you can migrate data out of your old archive into AWS, keeping the workflow that you're using today. So the next thing that we'll talk about is the volume gateway. And the volume gateway is volume storage presented over iSCSI. So you get an iSCSI LUN, just like if you had a SAN or storage array that supports iSCSI in your data center today. And all of the data that you write, all that block data, is going to be stored in the storage gateway service. Just like with tape, it's compressed and encrypted and then sent over an encrypted connection. It's stored in S3, and here you can take snapshots using the EBS snapshot service. So you get up to 16 terabytes of cache inside of that volume gateway virtual machine. And we have two modes. The first mode is cached, and with cached mode, you can have up to 32 terabyte LUNs, which represents 1 petabyte of addressable storage capacity back inside of the service. And you can mount that from any server or any workstation that supports iSCSI and start working with it. The second mode, stored volume mode, that's actually where we keep a copy of all of the data on the LUN inside of the virtual machine. So you can think of cached volume mode as being sort of thin provisioned, creating virtual volumes, because you can have 1 petabyte and it could be represented by 1 terabyte of cache capacity in the VM, but you could still have 1 petabyte of storage, and also 1 petabyte of data stored in the service. With the stored volume, all of the data is going to be stored in that virtual machine. So if you have 10 terabytes of data and you have a 16 terabyte LUN, you'll need 16 terabytes of capacity. 10 terabytes of it will be full. And so that means that all of your writes and all of your reads are going to happen to and from cache inside of that storage gateway virtual machine. So you're going to get high performance, low latency reads and writes, and you're going to have that durable offsite copy of the data in the storage gateway service that you can then take EBS snapshots of. And where this becomes interesting in a migration standpoint is that you can use this to migrate existing data out of your data center. So you can see on the left, we have an application server, we have an existing volume, and this would likely be on a SAN, or it can be, a VMDK or a VHD if you're in a virtual environment, but you're giving some storage to this application server, and it has a volume there and it's written data to it. Now, to use the storage gateway in stored volume mode as a migration tool, you would deploy the virtual machine in your data center, and you would take that volume, you would detach it from your application server, and you attach it to the storage gateway virtual machine. Now, inside of the storage gateway virtual machine, we're not going to rewrite any of the data. We won't format it. We're not going to write a new disk signature. Everything will stay as it was. And your application server is now going to connect to that LUN via iSCSI, and everything will look as it did when it was connected to it natively. But now that the storage gateway virtual machine is in the data path, we're going to take that data and we're going to start bootstrapping it, which means we're going to start copying it in aggregate blocks up into the storage gateway service and you can create a new volume. Now you can take a snapshot, and when you take that snapshot, this is where you can migrate that data and that workload up into AWS. Because once the data is done bootstrapping and we take our snapshot, now we can deploy a new EC2 instance. We can take that snapshot and it will be an EBS snapshot, which means we can turn it into an EBS volume, give it to that server. In this case, we've got a Windows server there. And now you can take the other infrastructure away and you have all of your data in your application server, and it's been migrated with the minimal amount of downtime and the minimal amount of overhead and effort to actually get the data and the application up into EC2 and running inside of AWS. Now I want to do a quick demo to show you what that actually looks like and how easy it is to take a snapshot of a storage gateway volume, give it to an EC2 instance, and have all of the data just be available and ready to go. So here we have the storage gateway console. You can see that I'm connected to US East 2, so this is in Ohio, and I have my demo gateway. You can see here that I have a volume. So we'll go and we'll look at the volume. It's 50 gigabytes. It's a relatively small volume. You can see that I have no snapshots. Now let's go and change to that desktop, and we'll go and look at the data that's on that volume. So this is my Windows instance. And you can see here that if I pull up Server Manager into File and Storage Services and look at disks, that I do have an iSCSI volume. It's coming from the Amazon Storage Gateway, and you can see that it's 50 gigabytes. It's also been formatted. It's mounted as my D drive. And if we go and look at the drive itself, you'll see on the D drive that I have a bunch of images. Now, I got all these images from NASA, from the NASA pages. All of these are public use. You can download them. So I downloaded a bunch of images, and we'll just open up the moon image here real quick. So you can see we have this image of the moon that we got from NASA, and that's on our D drive. And our D drive is our 50 gigabyte volume that's being presented by the storage gateway. So now we're going to go back over into the console. We're going to take a snapshot of that volume, and then we're going to mount that snapshot to an EC2 instance, and we're going to be able to see the same data inside of this instance connected up to our other. So first, I'm going to change over to the other, to the EC2 instance so that we can look and you can see that there's only one volume. So this is my other desktop. So you can see here that we only have one drive mounted. And if we look in Explorer, we only have the C drive. So now we're going to go back over into the AWS console. We're going to take our snapshot, and then we're going to provision that snapshot to this EC2 instance. So back in the console, this is our volume. And we're just going to go to Actions, Create EBS Snapshot, and we're going to name this Demo Volume, and we'll create our snapshot. So it's that simple. Now it's going to start creating the snapshot. I can actually click on this link, and it's going to take me into the part of the console where I can manage that snapshot. And this is where we're going to convert it into an EBS volume, and we're going to assign it to our Windows EC2 instance so that we can mount it and look at the data that's on it. So here you can see my snapshot status is completed. I just created the snapshot. My next action is to create a volume. So the only thing that I'm going to change here is the availability zone, and I'm just going to put it in the same AZ as the Windows instance that's running. And you can see that it's still a 50 gigabyte volume, so we're not changing anything else. We're just creating a volume from that snapshot. And now you can see we have a new volume ID, and I can click on that volume ID, and it's going to take me into the EBS part and filter on that volume ID specifically. And now I can take it and I can attach that volume to my Windows target. And it's that simple. I just took a snapshot of data inside of AWS from a server running in my lab. And I've taken that snapshot, I've converted it to an EBS volume, and I've given it to a server that's running inside of EC2. So now we're going to go back to our Windows server and refresh, and we'll see that volume show up, and we'll be able to go up and open that same image from NASA. So we've done our refresh. We're back on our Windows server. You can see here that 50 gigabyte volume. Now, instead of being iSCSI and being Amazon Storage Gateway, you can see that it's NVMe and that it's Amazon Elastic Block. If we minimize this and we go back here, you can see that our demo volume showed up. So you'll know that, or note that I didn't have to mount this inside of Windows because it already has a disk signature. It already had a drive letter. As soon as it's presented to this Windows server, because there was no drive D, this Windows server mounts it, recognizes the signature, and you can see that I'm able to go in and open up the same image that we were looking at before. Now, just so you know that these are two different desktops, I'll slide back. You can see that we're back on the original desktop, same exact image. So between the two desktops, we have two different instances of Windows running in two different locations. One is using the storage gateway virtual machine. We took a snapshot of that data and we gave it to an EC2 instance running in the cloud. So we just did a data migration in just a couple of minutes and deployed all of that data to the application server. So now to finish up, I do want to be sure that I point out the AWS Partner Network. So today I've mostly talked about, or I've really only talked about AWS solutions for moving data and migrating data into AWS. But we do have a very rich partner network, and those partners can do services themselves. So you'll see data migration on the first column there on the left. Those are all partners that can provide services to move data into AWS and applications and workloads. And then to the right, we have partners that specialize in things like backup and restore and archive, even building primary storage systems on top of AWS and business continuance and disaster recovery. So you can look to our partner network to provide not only services, but even solutions that we don't provide natively at AWS. And finally, the last thing is we have storage training that's available. So if you go to AWS training, you'll be able to go in and find courses, and we have a new line of free courses that are available where you can get deep dives on things like S3, EFS, EBS, storage gateway. We even have a migration and tiering course. You'll be able to go do all of those for free, and you can even use those courses as part of your certification process into the AWS certification. And with that, I'm going to take a pause, and I think we're going to go to Q&A.